let's go into the last part, the most important, difficult, and the trivial part. And this is about the real world, because I'm going to discuss about lossy case. Lossy case. It's very general lossy medium. I try to change that step by step. So what's D? D is we use epsilon E, okay? And for the lossless case, we don't have conductivity. So we don't have J, right? We don't have current because there's no conductivity. But we need to consider J this time. J is sigma times E. Okay. This one makes everything very complex. You will not see the friendly wave equations. You want this one. This one is simple, easy, clearly, right? No more. Not this one anymore. Because you want to check the lossy case. What happened for the lossy case? The same, we do the same technique again. We do twice the second curve of the first equation. Okay, we still don't have this part. Don't worry about M. The capital M does not exist. Don't need to worry about this one. This one will equal to minus J omega. B is mu H, right? Okay, so I take second curve. Did you follow? Okay, and now for the lossless case, we put J omega epsilon E, but now we need to put our J into this term. Okay? So things getting more complicated because you have this term. And you will take a curve on both of them. Okay? The difference is to derive the lossy case. The full equation for that one, we will have additional term of this term. Okay, because of the red one. Then you just take the same part, omega squared times mu epsilon, which is k squared outside, and you will have this new term, 1 minus J times sigma over omega epsilon. This is a new term. If this is lossless, or this is, you don't have the conductivity, you put 0 here, and this is 1, and it is beautiful. It's easy. But you have a lossy term, you have a sigma. Okay? It's not okay yet because we have more things to discuss. Let me write down this term. Okay. If you want to get into more details, maybe you can try by yourself. But what I'm going to do is you just do the same thing and you will obtain the same result. You will get this one plus k squared times 1 minus j sigma omega epsilon times E. I want to put that here. This term is new. Okay? For lossless case, sigma 0 is 1. And lossy case, we put everything here. Because you have epsilon E. Alright? Okay. Now, I want to talk about this one. Something that you textbook, right? But I want to discuss. This is helpful. Gamma. We talk about gamma equals to alpha plus j beta. Beta is our k. Okay? When we talk about this one, we talk about the k here. This is the something from our face. Our E field. Okay, look at our original, our structural E field. E equals to some amplitude times cosine omega t minus kz. Okay, we just look at the positive way. We just neglect. This is just very similar thing. Okay, look at this one. I want you to look at this one. So, if this one changing according to k and z, we just don't deal with omega t. This is your beta L in your circuit. This is something, the phase constant and your distance of your circuit, okay? This is, we also call the theta of this one. This is this term. Okay? If you look at this equation, what is cosine? Okay, 2 points. Anyone want to draw the cosine to maybe z? This is the cosine omega t minus beta z. Anyone? Raise your hand. Cosine. It's easy. 2 points. This one, and if omega and the t and the beta, they are constant, you don't need to care about, right? Just want to do something with z. Anyone raise your hand? You just, I just want a simple picture. Okay, just right now, it's easy, 2 points. Just right now. Yeah, you should write down carefully. I understand. Okay, let me ask you a question, okay? For the cosine, 2 pi, okay? This is 0, right? And this is 1. Okay? For cosine. And what is this? 2 pi. 2 pi, and this is not z. This, if this is a theta. This is a theta. This is 2 pi. Theta means everything. The phase. Okay? Okay? And if I change the theta to z, this one is lambda. Told you before. This is a 1 wavelength, and this is the cosine. Okay? And this is 1 and minus 1. Okay. One more question. Can anyone tell me what is the equation if alpha is some number? What is the equation of this one? Can someone? This is 5 points. Can anyone draw it? 5 points. Alpha is like 0.2 or 3, and come, draw it. 5 points. Because this is next up. Go to 5 points. Okay, so if you have an equation, look like this one. This is this one. Okay, another 5-point question. What happened if you multiply these two equations together? Raise your hand. 5 points. Multiply times this equation times this equation. Anyone? 5 points. Come. No, draw it. Try to draw it. That's why 5 points. You remember this is 1, right? This amplitude is 1 to minus 1, and this one is something like that. Can you try to draw? If you multiply this to this, too late. Someone occupied. Multiply them together, product. This one times this one. Can you get this times this? Did you see a picture? This one times. You don't know the answer, why you come here? Don't think that here. Can yeah. Yes, multiply. Do you want to give the opportunity to other people? I think there are some. Okay, come. Think the answer and raise your hand. about? You want more? Can you give us more details? Maybe you know the answer, but draw it carefully. Like you draw this one and you multiply them together. Maybe you can put an envelope. This is the envelope, right? Oh yes. Yeah. Now you get what I'm discussing. Envelope. Give me an envelope. Yes. Okay. Close. You are very close. Okay, anyone? Yes, you are very close, but okay. Yeah. Okay, 5. This is not 4 point, only 4 point. This is not a 1 anymore. You times that together, so this is exponential minus, when you put 0 equals 0, okay, this is 1. Yes, this is still 1. Okay, you are right. I want you to put the envelope here. The envelope here is the same, but divide by 2. Because you have 1 to minus 1 here, right? But now it's very similar one, not exact one. Your wave will become the ray 1. This is the real wave with loss. This is no loss. If you think about only beta, this is what you think. This is when you think about alpha and J beta. Because you times exponential minus alpha z to our original phasor form. Exponential j omega t minus beta z. This is our original phasor form, right? This one equal minus j omega t minus alpha j I want to get rid of omega t out first. I only think about beta z, okay? We don't consider omega. We put that together. This one will equal minus minus alpha plus j beta z. This is our complex propagational constant with loss. If you don't have loss, this is 0 minus become minus j b beta. Okay, this is important between lossy and lossless. And this is where gamma come from. So for our case, you need to think about the loss. You use not the minus j beta z. You use exponential minus gamma z. This is the equation you find out on the textbook. Okay? So this is different. When you discuss about lossless, it's J beta, right? Now is gamma only. This is alpha beta gamma. Gamma is alpha plus J beta. And this is the reason, because if we want to see the loss, this is how we use the loss, because the equation is like this one. Okay? Okay? And now, yeah, let's always end, getting more and more complex. We want to, okay, you have this one already, right? Okay, let me write down the original one. Lossless, right? You consider beta only. You consider gamma equals to alpha plus J beta. What do you want? You want if alpha equals to 0 in this equation. If alpha is 0 in this equation, will become this one. Okay, so alpha equals to. You want to obtain the equation from here to find your alpha to maintain the same relationship if alpha is 0, and there are more mass. What you are going to do is, if alpha is 0, alpha equals to gamma equals to alpha plus J beta. Okay, this is our definition. If alpha equals to 0, we look at what is gamma square is. Okay, gamma square equals to minus beta square. Right? So beta square will equals to minus gamma square. Okay? So it was beta square, this one. According to this relationship, you need to change this whole term to minus gamma square, not just gamma square. Okay? You need to think because of this J. This is a condition different that alpha is 0 or not, and we want to maintain the same relationship. If your alpha is 0, you have the same result. So your new equation of lossy case will become, right down here, minus gamma squared. Okay? I just try to explain why we have the minus here. Okay, because you have only, this is a positive k squared, right? But now you have minus gamma squared because of your, the j squared is minus 1. Something, maybe that's easier. So this is your new wave equation if that is a lossy case wave equation. Okay? And what is your wave exactly? Okay, maybe just show you the. Okay, and this is totally the same. If you cannot follow, you should go back to my PowerPoint. Okay, read that by yourself. This is a new term with lossy, and this is a lossless, the old term, and this is new, and this is old. And for the lossless one, is this one, and if you have a loss, you have alpha plus j beta equals to gamma. Okay, and you have a relationship gamma squared equals to minus k squared if alpha equals to 0. Then your wave equation will become these new types. Any question? Alpha is an attenuation constant. This one is an equation consider not only the phase, not only the cosine, but also the loss. So alpha, beta, gamma, this is gamma. Gamma equals to alpha plus j beta. You consider not only beta, but also the attenuation. So you will use these two equations with loss. This is more accurate if you consider loss. Any question?
Alpha 等于1的时候，不就是没有 loss？
Yes, yes. If that is loss, this equation will become lossless case. Maybe I have some mistake. I say alpha and gamma. Alpha is 0. If alpha is 0, gamma equals to j beta, and this is the old case, lossless case. If alpha is not 0, you will consider the attenuation and you will put everything here. Oh, I mean, if alpha is 0, no, I try to make them together. Doesn't mean alpha equals to 0. I try to have the relationship gamma equals to alpha plus j beta. If alpha 0, they are the same. I try to make them I'm trying to make the lossless case more sense. That is a special case if alpha is 0. I try to make them. Okay? If alpha is not 0, of course, this is not true. There will have some more complex part. Okay? I will discuss more, and you will have more. This is the true form of gamma. Because of this, if you want to get this one equals to alpha plus j beta square and take the negative part, you will obtain that your gamma will equal to this ugly part. And this one equals to alpha plus j beta. Okay? Your question is why? It is because I didn't write it down. That was an easy case. But the truth is, this is the truth case. If you put everything here. Okay? If you take this term and then read carefully about the real part and the imaginary part, you look at the real part and imaginary part of this term. This one is that one, right? The same, this is k squared, right? Okay? So that is your question, right? But now no question because it's complicated. Okay, so how do we deal with this ugly guy? This is it. I tried to explain this one at the beginning. I changed the direction. So now you are easy to understand why. See, the blue one is lossless, and red one, the pink one is the attenuation function. The red one is the final lossy wave. Okay. Then after all, you can check also, do the same thing as what we did before. You derive the wave impedance, right? Now you can derive another wave impedance, which become this gamma term. Okay, because you consider the conductivity, you consider loss here. So your eta become this one and also equal the epsilon square root of mu over epsilon. Okay? Do everything the same. And for this term, the epsilon, consider the conductivity, this is the lossy epsilon. If you do the lossy case, you need to think about everything in the lossy condition. Okay, what else? Now we still have time. Good conductor. The sigma, if this sigma is big enough or can be omniate, just if this one is very small, maybe you don't have this term, right? Or if this one is large compared to this one, that this term is larger than this term, what happened? This is a good conductor. If you are talking about a wave on the conductor, which has very large conductivity, this one, the red one, is very huge comparing to other part. When we derive alpha plus j beta equals to gamma, right? This term is ugly. But look at that. This term is the red one, comes from the red one, and this term was the original one. If that is the good conductor, what happened? This one larger than this one means the whole term is larger than 1. So you don't see this one. 1 is ominous. It's neglected. Okay? Then your equation become easy to understand because you don't have this one. Then you can take everything out. Then you will obtain this one. Okay. So tell me, what is alpha? 5 points, everyone, you are sleepy. So what is alpha? Raise your hand. So what is alpha? If that is a good conductor, what is alpha? Raise your hand. Easy question, 5 points.
Omega mu
Conductivity, sigma.
sigma over 2.
Take a square root. 5. Easy family. This is alpha. You times this one too, and the beta is J times also this one. If that is a good conductor, which means your sigma is larger than omega epsilon. If this term is larger than this term, you don't have 1. But if not, you cannot omit 1, right? But this one can become only this part, and you can take this easily. Okay? I already showed you at the beginning. Skin depth is 1 over alpha. Is a square root of 2 over 1. Right? I need to check. Oh yeah, it's 2. Yeah. See? The same. We derive it, right, from the beginning. Okay. Exercise. 10 points exercise. We have 10 minutes, right? Okay. 10 points. Maximum 10 points. Show me the answer. Why this one can become this one? 10 points. Try. This is only one part, right? Why you become 1 plus j? Why? Where is 1 plus j come from? Tell me, 10 points. Before 6:20, find out any way to tell me why this is a hint. What is the square root of minus j? If you know this one, you can get 10 points. This is a math question. Only one term. Why can it become 1 plus j? Why become 2 terms? Don't you feel weird? And if you know the answer, come to me. And other people can also earn the point. Okay? just come to me because almost time. And this is for today's class. Thanks for coming, everyone.
Come here. If you know the answer, just come to me.数学不能这样子，你知道吗？工程跟数学是两回事，数学要很准确。设计你在调那个规则，但是数学看你为什么？如果没有，我连省略我都会跟你说它为什么说什么，每一步我都是很准的跟你讲。你不能跟我说大概会是什么，没有就大概，然后这个。是我都不懂，它不是提出来，它是这个就变这个，它是整套哦，不是大概哦，这个不是等于这个，最少10个。你跟我说这个为什么会变这个，就这么简单。它没有变啊，你没有跟我说它的重点，它的原因，它为什么不是要变？它可以变成什么清楚？它是相等。This is a question my professor asked me in my preliminary exam. 博士资格考的问题，老师问我的问题。但是没有，现在想一想，没有那么难。It's not that hard. Because we have only 5 more minutes, I change the question to easy way. Okay, if you know, okay. You answer my question. The only question you need to answer me is, what is this? You tell me this one, that's it. If you don't know this, come here, 10 points. What is the answer? Write down and show me. What is this? Show me your answer. answer. Just give me the answer. Don't give me more questions. No. 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 I want answers. And the answer can lead to this. Why become two parts? There are answers on the website. People talk about what is this. How to calculate this one? Prove it. Prove this part. No if. I want answer only. No if. Give me what is this? Just write down. 啊？我只要答案，这个等于什么？